So this problem is very similar to the last problem, the garden problem, with a couple of differences, right? We're still looking at a rectangle. We're still given a relationship between length and width. But we have to be a little bit more careful when we're considering how we're going to assign our variables in this case, because what we're told is that the length of the court is 6 feet less than twice the width of the court. If I tell you the width, then, in order to figure out what the length is, you're going to potentially have to divide and subtract versus adding and multiplying. And so we want to be very, very careful. One of the things that you can do is start the process, right? We could also, we could solve this entire problem and then go back and look and make sure that we got what we wanted to get. There's nothing wrong with just starting. Let's let x equal the length. Don't allow the complexity to paralyze you, right? If x is the length, then we need to look at how we define the width. So the length of the court is 6 feet less than twice the width. That means that the width of the court, and this is where things start to get complicated, the width of the court in terms of the length, we're going to have to add and divide. I don't like the way this is starting, so let me start over again. Let's let x be the width. If x is the width, then we actually have a relationship that's written out here for the length. The length is 6 feet less than twice the width. So let's take the width, 2x, and subtract 6. And we can write that out, right? So if you allow that relationship to complicate things to the point where you get paralyzed and you don't move forward, then you're never going to solve the problem. It's much easier to get started and then see where things go, and don't be afraid to start over again. We could start all over again and just see if we can make things any easier. Once again, we're looking at perimeter, so that's length plus width plus length plus width is equal to, in this case, 266 feet. Our length is 2x minus 6. Our width is x. And we have an equation that we can start to solve. So we start looking at this. We have 2x plus x plus 2x plus x. That's 6x minus 12 equals 266. If we add 12 to both sides, we get 6x equals 278. If we divide both sides by 6, we get x equals 40. 6, let's see here, that's 240, 38, 6, 2. I'm not liking this. Oh, you know what? We're going to end up with a value that's not a decimal. And we're going to have to give it a fractional answer. And that's not the easiest thing to do when you're typing. Be careful. You can't just assign a decimal value to it unless the decimal and the fraction are exactly the same value. So in this case, 46.333333, which is the number that your calculator is going to give you, is different from 46 1/3. And so we just have to be careful to make sure that we're getting the number that we want to get. The court is 46 1/3 feet wide, and we got to do a little bit of calculation here. So we need to do 2 times x, so 2 times 46 1/3 is 92 2/3, and then we need to subtract 6, so that's 86 2/3 feet long. Not feeling great about my value, right? I'm not feeling like things are exactly what I want to see. And so I'm going to just take the time to make sure that I check things extra well. The relationship between the width and the length is right. I want to know whether or not my length, 86 2/3, plus my width, 46 and 1/3, plus my length, 86 and 2/3, plus my width, 46 and 1/3, is that equal to 266? And again, the fractions complicate things a little bit. The way I'm writing it in PowerPoint makes it a little bit more complicated. So don't be afraid. Go ahead, pull out your calculator, see what you end up with when you add them together. I'm going to add 86 and 46 and 86 and 46, and that's 264. And then if you notice, 2/3 and 1/3 is actually 1, and 2/3 and 1/3 is actually 1, and so I get 266 equals 266, and it checks. Okay.